Welcome, everyone. My name is Cathy Deino Blake. I'm director of the Campus Planning and Design Office at Stanford University and a fellow of the American Society of Landscape Architects. I'm very proud to be the outgoing vice chair of the GSD Alumni Council, where, as Walter Hood said earlier, the pandemic and many issues of the past 2 years gave us a pause and a time to think about what is important to our community. Hence the birth of the Design Impact series. I'd like to thank you all for attending today and all of the amazing people who've helped make today's forum possible. It is now my pleasure to welcome you to our 5th edition of Design Impact, Session 3 on climate change. A few years ago, scientists warned that climate change and global warming were causing irreparable damage to our planet and our cities, and that we only had about 30 years to right the ship. But do we? The past couple of years, we've experienced unprecedented heat and cold, damaging floods, drought, tornadoes, hurricanes, wildfires, and even a pandemic. Are we too late? Further, the International Panel on Climate Change's latest report predicts that the worsening impacts of climate change, especially heat stress, floods, and sea level rise, will be felt acutely in cities. The findings of hundreds of scientists show with increasing certainty that these types of extreme events will become increasingly more common. So how do we go about reversing this trend? In the next couple of sessions, we will look at this from different perspectives. In the first, Martha Schwartz will talk about what we, the design professionals who've helped construct our current environment, can do at a scientific and design level to mitigate some of the huge problems that we've helped to create. The following panels on regenerative design will also look at how we change our perspective and our human relationships with the environment to develop a more integrated future between man and nature. And now I'd like to introduce our keynote speaker, my dear friend, former classmate, and colleague, Martha Schwartz, to talk about climate change, tough talk, ground truths, future forward. Martha Schwartz is a fellow of the American Society of Landscape Architecture and a tenured professor at Harvard Graduate School of Design. She's a landscape architect, urbanist, and climate activist. Her work and teaching focus on the urban design, urban public realm, and its importance in making cities climate ready. For more than 40 years, she and the firm Martha Schwartz Partners gained fame with the projects around the globe, from site-specific art installations to public spaces, parks, master planning, and reclamation. She has now shifted her focus to strategic land use and landscape planning to assist leaders prepare for and combat climate change. Martha is a founding member of the Working Group of Sustainable Cities at the Harvard University Center for the Environment, a founding member of the Landscape Architecture Foundation's Working Group on Climate Change, and has recently founded Mayday.Earth, a nonprofit organization focused on climate communications and education for non-scientists and generalists about nature-based and geoengineering solutions, which act at a global scale and can be integrated into practice. Awarded the 2020 ASLA Design Medal, Professor Schwartz is the recipient of numerous international recognitions, including Honorary Royal Designer for the Industry Award in the United Kingdom, the Cooper Hewlett National Design Award, the Women in Design Award for Excellence from the Boston Society of Architects, Honorary Doctor of Science from University of Ulster in Belfast, Ireland, and Fellowship from the Urban Design Institute and Royal Institute of British Architects, just to name a few. So before Martha starts, I'd like to introduce our student moderator, Coco Tin. Coco is an architectural designer and researcher based in the United States and Hong Kong. She holds a Bachelor of Architecture degree from Cornell University and is pursuing a Master of Design degree at the Harvard GSD, focusing on expanding narratives of our intertwined ecologies. Coco will monitor your questions and throughout the talk and facilitate conversation with Martha to follow. So please do submit your questions. And now, Martha.
Okay. Thank you, Cathy. And by the way, you should take a close look at this one slide. Can you go back? Yeah, there we go. As an alum of the GSD class of 1977, I am totally honored to be part of this design impact event. And the GSD shield, if you take a look at that, is sitting on top of Cathy's head, who was my GSD roommate and best friend, and she still is. She invited me here, so if you don't like my presentation, it's her fault. Okay, thank you. So the title of my lecture is The More You Know, the Worse It Gets. I'd like to talk about the largest case of environmental inequity in the world, the Global South. The Global South is a term often used to identify lower income countries on one side of the so-called global North-South divide. So yeah, the Global South is a term often used to identify lower income countries on one side of the so-called global North-South divide. And the Global South countries are least responsible for causing climate change. And they're the ones suffering most from its effects, especially regarding food insecurity and nutrient deficiencies. Scientists warn we must act now. In the North, 25% of the global population owns 75% of the global wealth, and 86% of manufacturing industries are owned by and located in the North. And inversely, the South, with 75% of the world population, has access to 27% of the world's global wealth. The Earth is heating up from the south to the north, which puts the Global South in the front line of climate change, as these countries are closer to the equator and the climate is heating up there more quickly than in the Northern Hemisphere. The people in the South are experiencing now greater threats and suffering, much more than we in the North. And I believe that we global Northerners must find ways to help them, as we are responsible for what they are facing. So what about the countries of the Global South? We'll talk a little bit about some of them. Africa is one of the countries most affected by severe heat. An annual temperature increase for much of Africa is projected to fall within the range of 3 to 6 degrees centigrade by the end of the 21st century if high emissions continue. Business as usual. The rising temperature is likely to lead to deaths, displacement, climate-related conflict, irregular rainfall, drinking water shortages, and decrease in agricultural production. The frequency, intensity, and duration of extreme heat events are expected to increase. Climate change is an increasing threat to Africa. They are already experiencing many of them, such as rising sea level and coastal erosions, extreme weather events, increasing intensity in Africa. And this map shows deaths attributed to climate change in the year 2000, and already Africa has suffered by far the highest percentage of deaths. And we're talking about food security impacts, and agriculture is the backbone of Africa's economy and accounts for the majority of livelihoods across the continent. Global warming will challenge food security also, and risks of warming on agriculture include reduced crop productivity, increased pest damage, disease damage, and flood impacts on food systems infrastructures, resulting in serious adverse effects on food security and on livelihoods. Food security is endemic to almost all of the Global South countries. These are pictures taken from an article about the 10 most hungry countries in the world, and the large majority who suffer climate change impacts by far are women and children. So what about India? India stands to be one of the nations most significantly affected, given its huge population and levels of inequality and poverty. India is already experiencing severe and increasing heat that will disproportionately affect disadvantaged and vulnerable populations. In 2050, a heat wave killed thousands of people in India and Pakistan, and that could soon become the norm. Due to multiple effects of climate change, access to food in India is collapsing. Tropical cyclones will bring widespread flooding across the south, causing deaths affecting 1.8 million people, and rise in sea level will affect a total of 36 million people in the country by 2050. Groundwater makes up 40% of the country's water supply, but other sources are also running dry, and almost 2/3 of India's reservoirs are running below normal water levels. So when people show up needing water and food, it's non-negotiable. It causes social instability. Water supply is a huge concern in India and China. Social instability is being caused due to the meltwaters releasing too much water and then running dry. Long-standing border tensions erupted between China and India last June, leading to the first deadly conflict between the two nations in decades. The Tibetan Plateau is home to the largest store of freshwater outside of the North and South poles. It covers about 25% of China's surface. It is the source of some of the world's great rivers, and the meltwaters of the Himalayas feed water to China, Pakistan, India, Bangladesh, and South Asia's major rivers. However, the Himalayas are among the most impacted regions around the world by recent climate change, and temperatures are rising faster than anywhere else in Asia. In recent decades, this region has experienced rapidly increasing temperature and decreasing monsoon precipitation, meaning that it's losing water, but it's not getting more. At least 1/3 of the huge ice fields in the Himalayas are doomed to melt due to climate change. And these glaciers provide water for agriculture, hydropower, and household use as they melt annually. And the loss of the Himalayan glaciers will drastically affect all surrounding countries. 36 to 66 of these glaciers will be gone by 2100 if we don't stop. And even if we were to reach actually 1.5 degrees, it's still going to melt. And the melting glaciers could affect over 2 billion people. This is important to remember. By 2060, the authors estimated that 1.4 billion people will be displaced looking for food and water. However, there are even more problems. The scientific consensus says that no amount of adaptation or resilient planning can lead us to a stable, secure climate future. We actually have fallen short of goals, as we all know. The tipping points are starting to tip. The tipping points are the IPCC. Well, they say that methane reductions are probably the only way of staving off average global temperatures rising to 1.5. In other words, methane is 80 times more powerful a greenhouse gas than carbon dioxide. So we have to be looking at methane, and we don't know how much that's going to actually come out. It will take 50 to 75 years for us to actually make a transition. The economists study this, and it takes a very long time for us to transfer to a new energy. Now, we've actually run out of time. Cathy, we're asking, yes, we've run out of time to turn the ship. So what else could actually go wrong? Well, I have a question for you all. I would love to see raised hands. If we were to stop emitting today, would we have solved the climate crisis? Because that's certainly what I believed reading IPCC. Will the Earth cool down? No, wrong. The Earth will continue to warm up for a decade, at least, until the Earth can reach planetary equilibrium. But we would never come back to where we are now. Committed warming, that's called, is caused by the absorption of heat from the sun by the Earth. And it takes around at least 40 years for this warming that is embedded in the Earth to escape from the soils back to the atmosphere. However, this heating is not included in the IPCC metrics. So we actually have to add 1.4 into the future on top of whatever we are. So the ocean's albedo will decrease due to the melting ice. I hope you all know what albedo is, which means that it increases the reflection of light. And anyway, so the dark ocean surface will absorb more heat, which is released into the air, thereby raising the overall temperature. We got to remember that 1.4 degrees. Okay, this is a data visualization. A huge problem that we have is that we have 1,500 gigatons, and a gigaton is 1 billion tons, up in the atmosphere. That's what we've done, and it's sitting on top of us. It's not going anywhere. This data visualization shows Mount Carbon, which the mountain is 10 times higher than Mount Everest there, if you can see it at the bottom. This is how much carbon dioxide we have to pull out from the atmosphere in order for us to stabilize our climate at a temperature that we can live in. David Keith, a Harvard physicist and environmentalist, writes, carbon casts a long shadow onto the future. 1,000 years after we stop pumping carbon into the air, the warming will still be about half as large as it was on the day we stopped. In other words, carbon dioxide just sits there forever. Emissions are a problem and the major focus of our efforts, which is absolutely needed. But we seem to have ignored that the heat is the cause of most of the problems we are facing now and will continue to face even if we lower our emissions. And I've been thinking this through, that for whatever reasons, the information we're getting has avoided the issue of global warming. And I want you to think about this for two reasons. One, more people need to understand what the scientists are saying and coming out of science regarding unchecked global warming, because there is only one possible solution which can possibly check runaway global warming, which I'll get to. And number two, I want to say that the profession of landscape architecture can address both these problems, to draw down carbon dioxide and to cool the environment and cities through the deployment of nature-based solutions. So how can we ensure a safe climate for our children? So now, what kind of future are we going to choose? So what do we need to do to create a stable and safe climate? And we must do more than just reducing our emissions. So there are three other really important things that we have to do beyond that, which is to draw down our carbon dioxide in the atmosphere. We're going to have to cool down the planet. And lastly, of course, work to regenerate nature that we have put asunder. So how do we stop warming, global warming? This is a very important but overlooked piece of the climate change discourse, except for the scientists. But the scientists have been working on this issue of global warming for half a century. So they have known for this long what was coming our way, and they've actually prepared for it, thank God. So policy must assure our next generation's future. We must look at options that can not only reduce emissions, but will counteract the effects of global warming. So this is a case for climate intervention, commonly referred to as geoengineering, which is the deliberate and large-scale intervention in the Earth's climate system. As our planet enters a period of changing climate never before experienced in recorded human history, interest is growing in the potential for deliberate intervention in the climate system to counter climate change. Climate intervention studies the two major drivers of climate change, carbon dioxide and global warming. So what people don't really fully appreciate is that we have already geoengineered our planet. And most scientists consider we will have to employ geoengineering technology if we want to avoid the worst case scenarios. And the possibility of using geoengineering is deeply controversial. There is a wide range of technologies and practices that are considered under the umbrella of geoengineering. The one consistency is that these solutions are all at a scale that can have an effect on the planet. Geoengineering taxonomy has two major arms: solar geoengineering, also called solar radiation management and other names, and carbon dioxide removal. Okay, so carbon dioxide removal, I'll call it CDR, comes in three types: chemical, physical, and natural sources. And many of them pointed out by the green arrows include coastal blue carbon, accelerated weathering of rock, afforestation, and soil carbon, which are all relevant to landscape architecture. So we can use this in our practice. Landscape architecture, urban design, and planning are extremely relevant practices that deals with carbon capture and land management of natural systems. Land management is going to be one of the most important topics within climate change. This is a direct air capture machine. It sucks carbon dioxide directly out of the atmosphere. This has been, again, developed by David Keith, who is at the Gordon McKay Professor of Applied Physics for Harvard University Paulson School of Engineering and Applied Sciences. This very simple carbon dioxide it's a very simple machine in one sense, in that the carbon dioxide is separated from the air by a filter, condensed into a liquid-ish, high-pressured stream that is pumped into the ground for sequestration. And under the arm of carbon dioxide removal, there's a section called natural carbon dioxide removal. And this is the wheelhouse of landscape architecture, working with plants and soils which naturally absorb carbon dioxide. It turns out that landscape architects are the decarbonizing profession. Nature-based solutions should become a mainstream land management strategy, which provides solutions for restoring ecosystem services, which we need within our cities also, which directly feed into the realization of the Sustainable Development Goals of the United Nations. They will be key to rebuilding our cities to become climate ready, more resilient, more self-sufficient, sustainable, healthier, and happier. And the new landscape for the era of climate change, the new urban landscape, is something I would love to talk about. However, that will have to be for another time. Now we'll look at Solar Radiation Management Group, and specifically at Stratospheric Aerosol Intervention, or I will call SAI. In the end, this will be a political project that will have to be as political as it is scientific or technological. Solar geoengineering refers to proposed approaches to cool the Earth by reflecting solar radiation back to space, but they pose risks, challenges, and uncertainties. However, there is a building scientific consensus that we will need such methods to cool down the Earth due to many reasons. There are quite a number of different kinds of solar methods, all of which are about increasing albedo in order to reflect the sun's rays back out into space and cool the Earth. Ideas about using aerosols in the atmosphere to cool the Earth came out of scientific exploration of why volcanoes cooled the Earth after an explosion. And the cooling happened because of large amounts of sulfur aerosols reflecting incoming sunlight cooled the planet. In order to mimic the volcano, we need to get the aerosols up into the stratosphere. Planes would spray the aerosols carefully, controlling the rate of its release, which would remain aloft for a year, making them more effective reflecting sunlight. Eventually, they fall to Earth in a harmless form of sulfur dioxide, and research has confirmed that it would take less than a year to have an effect on climate change once it has been deployed. It will require continued treatments to the stratosphere, and once started will need to be done for decades, while carbon dioxide removal and weaning off of hydrocarbons get the climate under control. At that very point, SAI would need to be very gradually discontinued to avoid a massive rebound or reheating up the Earth. It's been reviewed and analyzed by the Royal Society Report, the world's oldest independent scientific academy in London, dedicated to promoting excellence in science. And this report, they say, quote, SAI could reduce the effects of global warming and its associated risks effectively, globally, rapidly, reversibly, and inexpensively. It also seems to be technologically feasible. A few grams of it in the stratosphere will offset the warming caused by a ton of carbon dioxide, and even the amount that would be needed by 2070 is dwarfed by the roughly 50 million metric tons of sulfur emitted by the burning of fossil fuels every year. However, at the same time, it could pose multiple serious physical risks and social challenges, all of which need research and study to be able to address these challenges. Nevertheless, solar engineering will likely be necessary to be a player within internationally agreed upon suite of methods to address global warming. But it is new and does need more research on both science and the governance. It is not ready to be deployed at this time. There are clearly obstacles and unknowns, but the consensus of the scientific community, is the sunlit scattering schemes need to be studied because while there are risks of deploying SAI, the risks of not deploying SAI could be many times worse. SAI has certain advantages over emissions cuts, adaptation, and carbon dioxide removal, and that its effects of counteracting climate change would be rapid. The tamping down of heat would address most of the serious challenges of climate change. However, in order to come to an opinion about the technology, it is fundamental that the risks and benefits are weighed carefully, as we are in a risk situation. So the risks may be large, such as the disruption of seasonal monsoonal rains affecting food production, hijacking of technology for harmful reasons. It could discourage a timely transition to renewable energy. Other countries can use it. Once started, it must be maintained. And although needed, international governance and agreements are unlikely to be met. Here are the upsides. Would be definitely large. The technology is simple and expensive and effective. It could stop polar ice cap, glaciers, and snowmelt, avoid drought and starvation, avoid continuation of the 6th great extinction, slow sea level rise and save coastal cities, avoid mass migrations, prevent climate wars and save billions of people, save the coral reefs in Amazon, provide global climate equity, and buy us the time we need to transition to renewables and teach our cultures how to live in balance with nature, which I hope we're going to hear next. So the failure to pursue research now on possible climate interventions would deprive future generations of options to limit climate harms. So this is called SCOPEX. This is the name of the first round of harmless outdoor experiments that was to be a balloon test flight to test the equipment in Sweden just this past June. It was canceled due to protests from the environmental organizations, many of them. And many people called the so-called radical environmental left are so deeply set against this. They are saying that there should be no research done on it ever. However, I and the majority of scientists disagree with the stance of disallowing research on a potential method of stabilizing the earth and halting the effect of global warming. We must consider an approach to something that can create a pathway to buy us the time to transfer to renewables and avoid intense suffering in the future of billions of people, especially in the global south. It would be a great relief to me and likely to a lot of other people, especially from the global south, if this could be tested. David is my brother-in-law, David Keith is the Gordon McKay professor. I told you that, and he is at the SEAS, the SEAS school. And he's one of the world's most influential researchers and voices on solar geoengineering. And he's one of the few who have done detailed engineering studies and logistical calculations on just how SAI might be carried out. In a 2014 paper in Nature found that among a variety of climate interventions, only SAI was able to return global average temperatures to pre-industrial levels. This is an important fact. It's the only likely solution on the table to tamp down global warming. But the greatest challenges to the successful deployment of SAI may actually be the social, ethical, legal, and political issues associated with regulation, rather than the scientific and technical issues. The key messages coming from the Harvard Solar Geoengineering Research Program are, given the urgent growing risk of climate change, it's important to understand the feasibility, risks, and benefits of solar geoengineering as a possible addition to the portfolio of response strategies. The second state of understanding of solar geoengineering is not sufficient for supporting informed decisions. In other words, we can't make decisions on it because we don't know. The US should establish, in coordination with other countries, a transdisciplinary solar geoengineering research program. This is something actually that we all can help on. Solar geoengineering research should operate under robust research governance. So, whatever one thinks about the potentials of this technology and its applications, there is a need for a forum to broaden the discussion about SAI into the mainstream conversation about climate change. And although research is unlikely to provide conclusive answers to all the questions about SAI, thorough and transparent research will put us in a better position to evaluate and make decisions about whether to intervene at all or how to respond to interventions by others. And without this response and knowledge, I believe it is given that the world will heat up more quickly to temperatures that will cause terrible suffering and social conflict. I would not like to pass this world on to my children. And just for your information, just recently in the past couple months, a lot of news has come out in the public about Washington, considering whether to pursue a research program for solar geoengineering in coordination with other nations, subject to governance and alongside a robust portfolio of other climate change mitigations and adaptation policies. The report emphasizes that solar geoengineering is not a substitute for reducing greenhouse gas emissions. Congressman Jerry McNerney from California has introduced new legislation, the Atmospheric Climate Intervention Research Act, to advance research on climate intervention. So the climate change is really extremely complex and overwhelming. However, there is so much to do and so much we all can do. We actually need to ask ourselves, like, what needs to be done? Maybe not on SAI, it's about what about the planet? What about ourselves? What about our kids? And who is going to do this? Are we going to do it? Somebody else going to do it? And how can I, as a person, do something? I know this because I've actually been there myself. In 2016, I heard a YouTube video on how the Eastern Siberian Arctic shelf is melting, the release of methane. So I just dropped landscape architecture and just started reading about climate change, and here I am. So I have started an organization called Mayday.Earth, and we hope to tackle two of the important things on how, about climate change. So we're really focusing on SAI and regenerating nature. And our missions are to support the research for stratospheric aerosol intervention, and second, to access to education on nature-based solutions and how they can tackle climate change. So we're just beginning. And I've been thinking a little bit more clearly about who my audience is. I wanted to tell you this. I didn't really plan on putting this in, but before Christmas, we are going to initiate a petition on behalf of support of research on stratospheric aerosol intervention. This is what I'm doing as a client activist and kind of going with my heart and sometimes even my brain. And the reason for petition is to create a voice that can counter the arguments against SAI and engage in a more balanced discussion. Very well-respected environmentalists and organizations within what is called the radical environmental left are against the idea of SAI, as I've said, to the point where they don't want to research it, and they don't even want to talk about it or say the word. They are disabling and disabled the actual thing they were going to be doing, the research they're going to do in Europe, in Sweden. They stopped it. And this was a harmless outdoor experiment. And they are able to do this and are doing this through harmless, even though it's harmless, through well-organized pressure. This seems unreasonable at a time when we need to consider what our next steps are if we do not achieve our goals. And the petition will focus on finding supporters within the Global South, as their voices must be heard through the petition. And of course, any of you who do wish to participate, please do, it can only help. Now, if you really want to actually do this, you can actually access our website to learn about the petition and actually put your email addresses on there. So when we actually get this out, we can send it to you and you can do this. But I want to say this, and if I have, I don't know, how much time do I have? I have 30 seconds. I have really something to say, and I'm going to say it even though the time is up. So I'm just saying, I'm a disruptor. I always am a disruptor. This morning, as I was putting on my eye makeup, I came up with the realization how important this group is. I have been at the GSD for 19 years, so I've forgotten this. But this morning I woke up. You can really help on this issue because you're a very important, powerful group of people. So I'm going to say this to you. I am going to be giving this petition out to certain groups of people around the world. I would like this. I'm asking you. I would like Harvard to actually be, I'm going to address this also to Harvard. And I would like you to actually participate with me to do this. That doesn't mean that if you don't want to sign it, you don't have to sign it, but we could build this. And I know this because Harvard is already getting these kinds of petitions from other groups about this. So all of us at this meeting, if you are interested in it, I know you don't know enough about it, we can prepare a packet of information so that you can learn more about it. And also, this is happening at Harvard, at SEAS. You can find this online. And the organizers of this event, if you want to help me figure out how we can actually organize this as a petition to Harvard, I would be very, very grateful. So I wanted to say this now, and in appreciation of really how strong Harvard can be as a place of real impact around the world. So thank you all very much.
And you threw a lot of information at us. I really appreciate it. So the title of the talk is also, part of the title is Tough Talks, Ground Truths. So I want to start, there's a question in the audience that is asking with a really tough question that's quite controversial. They're asking you if you have an attitude towards the relationship of climate change and global politics. And they're saying it's because it's a curiosity with the introduction that the topic of global north and south, and that itself, this north-south divide, is something that is very contested. Would you have any thoughts on that?
Well, I'm sure everything is contested, but you see that this is very healthy. And that's the purpose of what I'm saying today, is that we need a forum for these discussions, and we don't have one. So I would rather say, let's have that discussion with more than just me saying what I think, because a lot of people have thoughts, but we're going to have to go through this together. And the more together we are, the better off the world will be. So I think it's very important to ask these questions. Personally, I would love to hear the other side of it. There are risks also that SAI can actually hold on the global south. Absolutely, there are risks about it. However, that is the reason for doing a lot of this research. But there's also research going on in the global south to actually identify regional issues and climates, so that basically the scientists can design to address them. But when you start learning about the metrics of how many people are suffering right now and how many people are going to suffer before us, the idea of us saying or telling people that we cannot even research this, knowing where we're going, I think is immoral. So that's my position. I think it's unethical.
Thank you for that. And I guess on this note about ethical, there's a question also about the rebound effect of massive solar engineering. And yes, how do we ensure that if, for example, SAI is the method
discontinued,
so like how, for example, yes, maybe it is an option to buy us more time to transition, or like how do we ensure this isn't the perfect excuse to just keep doing business as usual?
We don't. We have people, we're dealing with people. This is the big problem. We are dealing with people. The actual chemistry and the technology is not a big deal. But I think that, this isn't going to be deployed unless we think it's a good thing to do, which is why we need to get on and go through all of this. We need to we don't even have a group of geoengineering governance put together. And we need to do this. We need to help the people at Harvard who are, working on this. Why can we not help? So if anybody has ideas about how we can, well, let me know, because together we can do things. Singularly as one person, we can't. But we need it. I mean, we need to govern, we need people who can govern the governance. It's going to take a while to do this. It's very political. But again, these are very good questions, because rebounding, it would be dangerous. And there are at least 8 other countries that could likely do this. And then there are countries who don't want to do it. Like Russia's pretty happy with global warming. They're growing their ability to actually grow crops. And they may not want to do it. Maybe they'll shoot down the planes. Maybe this, maybe this. Maybe we don't know what's going to happen when the tipping points are coming. Maybe we don't really know what's going to happen with the warming. We don't know. We don't know that either. So that's what I'm saying. We're in a risk world now. And I think a lot of these decisions are even individual decisions. It really has to do where our own moral compasses are and what we believe in. So it's a mess. It's a complicated mess.
Agreed. Well, on that note, there are a bunch of questions about what are the specific roles for landscape architects in the design community in influencing this research. You spoke about the organization that you're running. Are there other avenues that you can adopt or use of SAI? You can also talk more about.
Well, here's the deal. I have been teaching for a few years now a class called geoengineering, a geoengineering toolkit for designers. And honestly, there are so many pieces of this geoengineering, which are so many other things that can be done within this umbrella. It's amazing. You know, the crushed, the rock weathering thing is now coming out as the answer for regenerating the soils in degenerated agricultural fields. That comes out of geoengineering. There's so much stuff that we don't know about, that by bumping up to this kind of bigger scale of knowledge about climate systems. I mean, we learn about ecology, that our profession is both design based on science. But if you go up to the Earth system, that's another realm of science. And if you start understanding all those systems, you understand how integrated what we do really are. But that also gives us a lot of energy for more creativity. That's what happened to me. So I actually did a project. I can't say what it is, but I started really introducing these ideas into practice. And it's glorious. It's really good. It's really unbelievable. And even technologies like direct air capture machines are coming up. And in the project, there are direct air capture machines that can take down carbon dioxide and put it into what are they? They're greenhouses, seawater greenhouses they're called. And when you pump in carbon dioxide, you can get 3 different rounds of crops because the plants love carbon dioxide. We can make more food from that, and while drawing down carbon dioxide. Yeah, sorry.
That's a great note to end on. I love the positive thinking of things we haven't thought about in landscape architecture. And so I want to thank both you and Coco and our audience so much. And there have been great questions. We can take a look at those, when we're done. And you've given us a lot to think about and a challenge to act. And so now, everyone, please stay with us for the next session, Regenerative Design, which will start in just a few moments.